Okay, I'll try to do a very easy problem. Like I know there are like lots of very young audience, including my daughter, like so there's like they're starting from grade 5. So we'll try to do like a very easy problem, but it's still like an IMO problem. So the thing is like my IMO was like 2001 and 2002. Okay, so that was like a gold and a silver, but that was like way back. So that means so the problems have gotten exponentially harder with time. I think that's my feeling. So back in the old days, the problems were much easier. So, or that's the feeling I have. So I haven't kept track, but I'm pretty sure I won't be able to solve any problem right now in 4.5 hours. But back in those days, like so we were like, so let me like give like I'll try to tell the story of like the Olympiad type things. So I was of course growing up in India. So like my IMO gold was from India. So the 2001 and the 2001 IMO actually happened in the US. So we actually came to US. That was my first time I visited Washington, DC. So the IMO 2001 happened in Washington, DC. So the way that it happens in India is like, it's very similar to the way it happens in the US. In the US, the process is you do AMC 10 or 12, then you do AIME, then you do USMO, then you most probably go to a camp. And then I'm not sure actually, and then the team is selected and things like that. So the Indian IMO is similar. So there is a regional test, then there is a national test. Then you go to a camp, and then from there they select the team of 6 people, 6 kids. And then what they do is, it's kind of a fun thing. Before flying out to the country, they have a pre-departure camp where we go to some Indian university and we stay there for 1 week, just the team and the deputy leader. So there is always a team leader and a deputy leader. So the deputy leader and the team, they stay in this camp for 1 week, and then all day we just do puzzles, do problems, like do old IMO problems, old shortlist problems, and then play lots of board games. We play lots of board games. Chess is always popular, okay, and solve chess puzzles, okay. So this problem I encountered there. So we were like doing old IMO problems. So here is a problem, okay. So the problem is, and it's an easy problem compared to the recent problems. It's very, very easy. So there is this guy called Peter. I remember the name. It was Peter, okay. So Peter has 3 bank accounts. 3 bank accounts with a positive integer number of dollars, with positive integer dollars, okay? Okay, and then he can make transfers. So can make transfers. Of course, you cannot have negative money in a bank. You can make transfers so that the money in the recipient account is doubled. Okay, so you can only make these transfers. So you can only transfer money so that the money, like the account to which you're transferring the money to, that doubles. Okay, so that's his rules. Okay, and then prove that after some transfers, he can do transfers to empty an account, to empty out an account. So you can ensure that he has $0 left in one of the accounts, okay? So that's it, that's this problem, okay? So I'll like leave you guys to think about it while I keep telling stories, because it was like it brought back lots of nice old memories. So what happened is like, so the way we worked in the camp is that, so this was actually not an actual IMO problem. If you're like going through all the IMO problems, this was an IMO shortlist problem. So it's a slight lie. This is not an IMO problem, this is an IMO shortlist problem. So for those of you who don't know, the way this IMO shortlist works is that every country proposes some number of problems. Some countries propose none, some countries propose more than one, and these are then they are shortlisted. So then they create like some big shortlist of problems, which then the IMO organizing committee goes through and then decide what the final 6 problems are going to be. Okay? And then they embargo the shortlist. They don't release the shortlist immediately, because then this shortlist is discussed with all the different team leaders from all the different countries. So every country gets the shortlist for that year, and they basically reuse the shortlist problems for their national competitions. So like the USMO might use the IMO shortlist from the previous year, okay? And then Indian IMO definitely does that, okay? So we use the shortlist, and then eventually they're all released. So all the shortlist problems are eventually released. So when Oleg asked me to do this, I tried to look this up, and Google is great. So I looked up Peter, 3 bank accounts, IMO shortlist, and lo and behold, this was a 1994 shortlist. Okay, we figured it out, okay, with Google. But anyways, so this was a 94 shortlist problem. So that is like way back. So then the problems were very easy. So this is actually, again, an easy problem in the sense that the solution is going to be very, very simple, okay? So the solution is very simple. But again, it's hard to estimate the difficulty of problems, because the reason this problem sort of stayed my favorite, or I remembered it still, in contrast with the other problems, is because when we were like trying to solve this, the way it worked is like we did an IMO, mock IMO every morning. We woke up and there was like a 4.5 hours for 3-4 problems. We were trying to solve it. And then whatever we couldn't solve, after lunch, all of us collectively got together and solved them, okay? So collective problem solving is way more fun because you collaborate with others, you talk, except in the actual IMO, you don't get to do that. So that was the morning practice. And in the afternoon, we would collaborate and talk, then dinner, and then we would play games, mostly chess, okay? So that was the day. Except this one we couldn't solve, okay? So we couldn't solve it in the morning individually. Then we talked with each other and we couldn't solve, and that was actually day one. So we couldn't solve it in day one. Usually whenever we start collectively working, we could solve anything, okay? So like 6 of us could solve anything, like because we exchange ideas, right? But this one we couldn't solve. It was just like we're completely stuck. And then day 2, we couldn't solve it. Day 3, we couldn't solve it. Our team leader got involved, our deputy leader got involved, and together we could still not solve it. So this was like totally bothering us. We're like, what does Peter do? We're like, what is this Peter guy? Like, what's going on with him? And then we were trying small numbers. Of course, you try small numbers, right? But we couldn't figure out a strategy. So let me give you an example. Instead of preventing the solution, okay? Let me tell you our frustration for the whole week, okay? So like let's say you take 5, 8, and 11. This is a very small thing. We were trying much bigger numbers, okay? So you are allowed to make transfers. So at any stage, you're always allowed to make 3 transfers. You could transfer from the middle account. So we can, like, let's say the amounts are L less than equal to M less than equal to N. So the 3 money. So this is like the 3 amounts. So you can always transfer from the middle account to the smallest account, from the largest account to the smallest account, or from the largest account to the middle account. So those are your 3 transfer opportunities. So let's say you transfer from 8 to 5. Well, you have to double 5. So this becomes 3, and that stays 11. So again, you could have done other things. You could have transferred from 11 to 5, or you could have transferred from 11 to 8. Okay, let's just play around. So this seems like a good idea. 11 to 10. So then this becomes 20, this becomes 3, this becomes 1. Okay, then this seems like a good idea. So 20, this becomes 2, so this becomes 2, and then aha. So then we transfer from here to here, so that becomes 20, this becomes 0, and that becomes 4. So we have managed to empty out in this account, right? So that's like, so you look at, this is a very small number. You just look at this, and these are sort of the obvious moves that you do, okay? And then you empty out an account. So as you realize, what we are trying to do is like, we start with some configuration like this. There are always 3 moves available. There are 3 possible moves. Okay, I should switch from red. There is no reason to keep using red. Okay, so there are 3 possible moves, but it's hard to figure out which move to do. Like which one should I, like what to choose? Like what move should I do? What move is better? I mean, that's the tricky thing. Like, of course, if you do randomly, you might be going around in a circle. Like here is an example. Let's say the amounts are like 4, 8, 13. Like I'm just giving an example. Like if you're just doing randomly, let's say you transfer from 8 to 4, well, this just becomes 8, 4, 13, and you're back to where you started. So you could be going around in a circle. Like here, you started here, you did this transfer, you're back to where you started. So this is a very short. So you could be like, there are loops. So this is something that we could call a loop. There are loops. This is a very short loop. You just do this transfer and you're back to where you started. There are longer loops. Like we tried fiddling around, and you can do a long loop and come back to where you started. So if you just do things randomly, you might be going around in circles. The other thing is like, what are the obvious, what are the obvious sort of things you could try to do? You could say, always move money from the middle account to the smallest account. Like, here is like, so move from middle account, middle to the smallest. If you do it all the time, that fails, like in this example. If you always move from the middle account to the smallest account, you just stay where you are. So that doesn't help here. You could try to do like make the transfer between the accounts whose difference is the smallest, like transfer when the difference is smallest. That also doesn't work. Difference is smallest. So if you try to come up with any fixed strategy, that sort of doesn't work. So this also doesn't work. There were lots of examples we found, and almost any strategy that we were trying to do was not working. Okay, so hence the frustration. And then there is an obvious thing that one is trying to do here, right? So you are starting with some configuration. Let me write it out again. So you have, these are the initial money, L less than M less than N. So in some sense, this is the starting configuration, and this is the smallest one, right? This is the minimum. So the minimum is L, and you want to make transfers which reduces the minimum. So we want to like do some transfers that decrease L, right? It decreases the minimum. You can assume the minimum is positive. So if you can decrease the minimum, then you win, right? Because then you do some transfer, you decrease the minimum. If you know how to do that, then you decrease the minimum again, and you keep going until the minimum becomes 0, right? So that's like the obvious complexity, right? You should look at the minimum, and you should figure out how to decrease the minimum, okay? So, except it was not quite easy, right? So that's why I think this is a hard problem. I don't know. Maybe some are like, because again, the problems have become so much harder. Maybe the modern IMO kids, you can look at it and you can immediately tell the solution. But in us, 6 of us, we had no idea. But then luckily, just before leaving for Washington, D.C., I did manage to solve it. So I really, really enjoyed that, and it became my favorite problem. I really, really liked that. And that was basically the official solution. So, and the official solution is extremely simple. And that's why these solutions are so deceptive. Like, to actually see whether the problem is hard or problem is easy, the only test is try to do it yourself, okay? Like, if you hear the solution, like that problem, it's like a brilliant problem, the monsters and things. The solution is like so simple, like go around in a staircase, right? If somebody says, go around in a staircase, you have solved it. I mean, honestly, to solve that, you just need one word hint. Staircase, and then any IMO kid would solve it in like 5 minutes, okay? If they say staircase. But the thing is like, you don't get that idea. So ideas are generally one word hints, and then you have solved it, but it's hard to get to that idea, okay? There are lots of words in English language is, I think, the problem. So here is, so here is a solution, but again, that will ruin the problem, but unfortunately that's all. If this is being recorded, if you're watching this on video, you should stop the video and try to solve it, at least for half an hour. Then it's like really fun, because you play around with small configurations and see what the idea is, okay? Unfortunately for the live audience, I'm going to spoil the problem for you and give you the solution, okay? You could also leave, and then that way, that I won't mind. Okay, so here is a solution. I think that was the official solution, and it's a fairly easy solution. And the way it does is like, here is the one word hint. So this is my starting configuration. You look at the middle amount, you divide by the lowest amount. So you look at this, so you take the middle amount, you divide by the lowest amount. That's some number. You take the floor. So this is some number bigger than or equal to 1 by assumption. So you take the floor, that's some number bigger than 1. And this integer, this is some integer. This positive integer, you write it in binary. You write in binary. And that's the hint. Okay, and now all the IMO kids would have been like, okay, then they would solve it immediately. So that's the tricky thing. And then again, in hindsight, this makes so much sense, right? Of course you use binary, because this is all about doubling, right? You're doubling the amount. So of course you should use binary. We thought of that also. Like of course, we also thought of binary. We were like, what we did is like, we looked at these 3 amounts. I mean, we know binary is a trick. So we did write these 3 numbers in binary. But we never wrote down the quotient in binary, okay? So we were like, and eventually we wrote down the quotient in binary, and then it works, okay? So this is, of course, the quotient. So like, I mean, I just wrote it in a fancy way. This is the trick. That's the solution, okay? Now I'm going to explain the rest, okay? How this is a solution. So what you do is, so all I'm basically said is that if you divide m by L, so let's say this, so if you divide m by, okay, so let me write out the binary number. So this number is in binary, so that means it's of this form. So binary is just base 2, right, instead of base 10 for the younger audience. So you write this number of the form a0 plus a1 times 2 plus a2 times 2 square up to ak times 2 to the k. So these ai's are 0 or 1. These are the digits of the binary number. These are the digits. I wrote it in powers of 2. And this is the last digit. This is the highest digit. So I can assume that ak is 1. OK, this is the highest digit. Great. I still wrote it out like this. But this is the highest digit, which is 1. That will be relevant. And everything else is 0 or 1. Right? So you wrote this in binary. OK. And this is just division, okay? Like what this means is that if you divide m is bigger. If you divide m by L, this is the quotient and there is some remainder. That's all this means. So m is like you divide by L, then we have some quotient. This is the quotient. A0 plus A1 2 plus A2 2 square up to AK 2 to the k, plus some remainder. And the important thing is, this is a remainder, so you're dividing, so you're like divide m by L, okay? So this, because this is a remainder, R is bigger than or equal to 0 and less than L. That's what remainders do. That's important. I'm boxing everything that's important, okay? This is important, that's important, that's important, okay? So, and then, great. So now you sort of know what to do because you have these 3 bank accounts. Let's say the accounts are account 1, account 2, account 3. You will just keep on transferring into the account 1. Just keep transferring into 1. Keep transferring into 1. Just account 1 until it becomes, so every time you transfer it doubles, right? So every time you transfer it doubles, so until it becomes 2 to the k plus 1 L. This k is same as that k. So you double until it becomes this. So only thing I have to tell you is that whether you're transferring from account 2 or whether you're transferring from account 3, and here is the rule. So by the way, what are the transfer amounts? So the first time you transfer, you are doubling it. So the first transfer amount, so the transfer amounts are, the first time you transfer, you're transferring L. The second time you transfer, you're transferring 2L. The third time you transfer, you're transferring 2 square L. So the last time you transfer, you're transferring 2 to the KL. So these are your transfer amounts, which you notice are exactly the things that appear here. So these are the amounts that you're transferring. So, and the rule is that when you're making the transfer of this amount, 2 to the I times L, so one of these things, when you're transferring 2 to the I times L, transfer from account 2 if AI is 1, and transfer from account 3 if AI is 0. So AIs are the digits of the binary number. So depending on whether they are 1 or 0, you transfer from account 2 or account 3. That's your rule. It's a very simple rule. Once this thing is written out, it's like absolutely simple that what you have to do. And then what happens is that after all these transfers, what remains, so after the transfer is done, after the transfers, what is the amount that I have? Well, the first bank has 2 to the k1 times L. That's the amount in the bank account 1. In bank account 2, well, how much have I transferred? I started with M. And what have I transferred out? Well, I transferred a 2 to the I times L if and only if AI was 1. So I have exactly transferred this amount out from it. So it's M minus L times A0 plus A1 2 plus A2 2 square up to AK 2 to the K. This is exactly the amount that I've transferred out from the second account. And from the third account, I've transferred something. It's hard to write down, but okay. So I have transferred the rest. from the third account. So from the third account, I have transferred the rest. And so we are almost done. So there's a very little thing we have to do to make sure you get 7 points instead of 6. So the only thing you have to write after this is like, okay, so you have to make sure that these transfers are valid. Okay, let's see. Yeah, so these are so this is like these are valid transfers. These are valid wire transfers. Okay, valid transfers. So the thing that you have to make sure is that you don't have negative balance. You cannot transfer money for ordinary people. You cannot transfer money from an account to another account and get negative amounts. Okay, extraordinary people can do that. But so you have to make sure that these are non-negative amounts left. So you have to ensure that this is non-negative and this is non-negative. But this is clearly non-negative because, right, look at this equation. This is the amount I have transferred from M, so I'm left with R. So this amount is exactly equals R. I'll put it right here. And R was non-negative right here. Okay? So this is actually the remainder. So R was non-negative. So the transferring from account 2 is fine. Okay, and a little bit of argument shows that that one is also non-negative. And why is that? Because I'll just write it. Because the amount transferred from 3, well, what is the maximum I could transfer? It's less than or equal to, well, the worst case, the maximum amount I could transfer from 3 is that I'm transferring every single one of these. I'm making every single of these transfers from 3. Okay, so I'm transferring this from 3, I'm transferring this from 3, and so on, except the last one. The last one I have to transfer from 2, because the last one is AK is 1, it's boxed. Because AK is 1, the last transfer I am making from 2. But except the last one, everything else I could be transferring from 3. So the maximum amount of transfer that I could do from 3 is, well, everything else. L times 1 plus 2 square up to 2 to the k minus 1. That is the maximum I could transfer out from 3. And the sum of powers of 2 is actually less than the next power, which is 2 to the k. Right? And this is less than or equal to m, because 2 to the k times L actually appears in the expression for m. It's right here. 2 to the k times L appears in the expression for m. So this is less than or equal to m, which is less than or equal to n. That is actually no longer boxed. It used to be boxed here. Okay? So the maximum transfer I do out from the third account is less than n. So this number is non-negative as well. So these are all valid transfers. So after all these transfers, the first account has this much. This account has R, and this account is still a non-negative amount. And the point is that now we win, because the amount left here is the remainder, which is less than L. So R is less than L. So after all these transfers, we have managed to decrease the smallest amount. Okay, so and that's the valid strategy. So it's like, it's really a fun strategy. And of course, if you explain the problem, like particularly if you just write this out, it's immediate what the solution is. But we had a hard time finding it. 6 of us, it took 7 days to get here. So so I really like this problem. It's a very simple, cute problem, and it got us stuck for a week. So we had fun with it. Yeah. So I'll just.
Dear friends, thank you very much for watching videos on our channel. At the end of this conference, I would like to thank the people who made it possible, in addition to the speakers. First of all, 2 brilliant UCLA administrators, Ronke Epps and Janet Kropat. And second, the person who gave us the money, the math circle of the money to make this wonderful video, Dan Gold. A great many thanks to Ronke, Janet, and to Dan for making possible to share this light with the rest of the world.